having run a bike shop for a decade, I probably thought I knew more about carbon production than 99% of the population. And I might have, but I've now realized how much I didn't know. And, this 2 years has been an amazing education and learning curve in terms of engineering and the complexities of carbon production, manufacturing in general, and just starting your own business. So I think what Frank said is on the money. If I had known what I know now, I probably would have been a little bit terrified.
Huh.
So,
I do everything. I cleaned the toilets this morning.
That's right. It's a small business. I forgot.
So my name is Frank Gardner. I'm a co-founder of Bridge Bike Works. I've got a lot of experience in starting companies, mostly manufacturing companies making products locally. Super passionate cyclist, and back 2 or 3 years ago decided to team up with Mike to start the company and kind of make something that we're fully passionate about.
That's Frank. He and I and his business partner Mike are in a factory in an industrial part of northwest Toronto. Frank and Mike have been planning and building this space for close to 2 years. It's about 85 to 90% complete, according to Frank. It's spacious, well lit. It has a CNC vertical mill, an automated cutting machine, a heated press, an oven, 3D printers, and other machines too.
My name is Michael Yakubovich. I'm the other co-founder of Bridge Bike Works. I've been the owner and founder of Blacksmith Cycle, now in our 11th year, a boutique bike shop in Toronto, and also through that shop focused on designing and building handmade bicycles. So I've been involved in the design and production of a number of industry-leading handmade road and gravel bikes, and just super excited to finally be able to put that experience and passion into my own project, and thrilled with being able to work with Frank and kind of combine our skill sets into something pretty special.
Mike and Frank are going to make carbon fiber bikes right here in Toronto. Now, a lot of companies say they make bikes. Sometimes that means they design bikes in Canada, the US, or Italy that are then built in Taiwan, China, or Vietnam. There are carbon fiber bikes made outside of Asia, but it's not common. Frank and Mike, though, are going to take sheets of carbon fiber, cut them, form them, bake them, bond them, and finish them all in their factory. They're going to make frames and forks right here. The first model is called the Surveyor. It's not out yet. They're planning to have their first bikes rolling out of here in June. To me, it seems like a crazy ambitious plan. This is the Canadian Cycling Magazine podcast. I'm Matthew Pioro. Join me on a tour of the Bridge Bike Works factory to learn just how a carbon fiber bike is made. This look inside the factory will help you understand your whip even better, no matter where it was created. I'm also going to find out why these two Canadian guys think it's a good idea to work with composites right here at home.
We are excited to show you what we got going on.
Frank leads the tour, which makes sense. He's started manufacturing companies before. He's worked with metal, making trigger systems for crossbows and firearms, and later with carbon fiber powerboats, all locally. He starts by telling me about all the variables the team at Bridge Bike Works have to manage when they work with carbon.
Everything in composites is process related. So I spent a lot of time in the metal space prior to getting into composites. And the big difference in my mind is, you get a chunk of aluminum and it's a homogeneous thing. It's just aluminum. Whereas, and then you cut into it and make a shape, basically, right? But at the end, you just have an aluminum shape. Whereas with composites, you're both making the material and making the part at the same time. And so that's why you have to control it so much. Like if you orient your unidirectional in one way by mistake, your part's different. It's going to perform differently. It's going to whatever. If you sneeze on it, it's going to be different. If your hair drops into it, it's going to be different. So it's a unique thing in that way. Obviously, that can be irritating to a lot of process people and workers, but you just have to have your process down and control everything.
Frank and Mike have ensured that they control temperature, humidity, and dust. Carbon dust can be nasty stuff, not just for your lungs. It's conductive, so it can mess up the electronics of the expensive machines in the factory. Frank then goes deeper into carbon fiber itself.
We use pre-preg carbon. So pre-preg basically means pre-impregnated. So that means the epoxy or whatever resin that someone is using, we're using epoxy, is already in the fabric. So it comes frozen, and we have to immediately put that into our walk-in freezer here. So you'll see here.
They were opening the fridge. It's pretty noisy.
So this is what's called a kit. So every single piece of carbon that goes into our head tube is in this bag.
How many pieces are in that bag?
Roughly 70.
70 pieces for just the head tube.
Just the head tube, yeah. I was going to show you some scraps just so you could feel. Do you want to feel the raw material?
Totally, I want to feel the raw material.
We can go in the other room if you want.
Yeah.
A little quieter. So this is unidirectional. The majority of our parts are all made from uni. And all uni means is that the fibers are all going in one direction. Most people are used to seeing weave, and they think that's what carbon is, but most bikes and most high-end products, I would say, are that aren't just for aesthetics, are made with unidirectional. So it's interesting here, you can see how flimsy it is in its raw state. So like you can just pull the corner, right? It's just gonna come off.
I ripped it,
Yeah.
and it feels almost like a bad sticker.
Like a vinyl.
Like yeah, exactly, like some vinyl.
But then pull it in the direction of the fibers.
Okay, now pulling in the direction of the fibers, and I cannot break it.
Next, Frank takes me to a tall, imposing machine. It's his favorite machine in the factory. His two boys think it's super cool too. It's a CNC vertical mill. He and his team use it to create molds, or tools as Frank calls them, that they use to form carbon pieces later on.
So that machine takes our raw aluminum, which you'll see in the shop as well. We just have these bars of extruded aluminum that we cut to the size of our tool, put it into the CNC. Our engineer Thanos Drivas, who used to be with Cervelo for 6 or 7 years as one of their lead R&D engineers, does all the cam, does all the tool design, and that machine basically just cuts it all out. The biggest benefit of this machine is that we control the tooling. And the tooling, some people call it molds, we use it interchangeably, is essentially the representation of your part. Your part is really only going to be as good as your mold is. And for us, because we're doing everything in-house and locally, we figured that was the best thing you could control in your process, would be, okay, we're going to control it from the design, the engineering, and also the tooling right from the get-go. So we know absolutely every single measurement that goes into those tools that then leads to the part.
The tools or molds that Frank is talking about are heavy blocks of aluminum. When Frank shows me the two halves of the tool for the head tube, it's easy to see the shape of the section you'd see at the front of a bike. Bridge's first bike, the Surveyor, will come in 5 sizes, so the team needs to make 5 tools for each head tube. Some of the molds will work on a few frame sizes as the parts can be trimmed. Bridge's frames are made with a lug and tube system. This is in contrast to what is often called monocoque or semi-monocoque, where a good portion of the frame is made with one big mold. With Bridge bikes, there are molds for various tubes which are then joined together.
So I basically consider the tool like the golden egg of the shop. You care for it, you treat it well. It needs good vibes in order to help you with your whole process. It's the most critical part of your process, and if you get it wrong, 1, you're not going to get a good part. 2, you're going to spend way more time putting your raw carbon in and then taking the parts out. They call it releasing the mold, or releasing the part, I should say. And you're just going to spend way more time on that, so that your tooling is just essential.
He's not really exaggerating. He lets me handle the mold for the top tube. Even though it's made of 2 heavy pieces of aluminum, a very durable material, I handle it like the golden egg Frank says it is. It's more like it's one of the shop's Fabergé eggs. There is no way I'm going to put a ding or nick in it, which would totally ruin the tool. From the CNC machine, we go to the cutting table. Remember that package of carbon fiber that Frank showed me? The kit for the head tube with 70 pieces in it? The pieces for the kit are cut out at this table.
So as soon as the material's thawed out, we lay it down on our Autometrics cutting table. That's right here. It basically just looks like a very big, long table, and it's got a computer head on it. And this reads from the computer that has a nesting program, and it puts in all of our laminate schedule sizes. So all of those 70 pieces in the head tube that you saw, this cuts it out in probably like 30 seconds, a minute kind of thing, where it would take a human like 4 or 5 hours. So it's an unbelievable advantage. And remember when we were talking about how important process is, this allows you to make each piece of your laminate exactly the same every time. Whereas if you're hand cutting it, you're always going to have little differences here and there. So a massive, massive benefit here. And the nice little thing about this too, it's got a marker on it, just a simple Sharpie. So when it's done cutting, it labels it.
You hear that term? Laminate schedule? That's a pretty important term that I ask Frank to unpack. And then Mike comes in with some additional information.
Yeah, so a laminate schedule is really like a paint by numbers type thing. It is each and every piece that goes into a part in order of it being laid up. So that's what it is. So you have, you could have a rectangular shape like this. You could have one of those bigger square shapes that you saw in the head tube kit. Those are all part of the laminate schedule. And that's also part of what that machine kind of writes on. So it'll write that part number related to where it is in that schedule. So it's really a build book.
And that's a little bit of the magic, and having world-class engineers in-house who've designed dozens of high-end race bikes is the laminate schedule really takes the engineering shapes of the frame and dials in things like relative stiffness, ride quality. The weight of the frame obviously is a big factor in how much carbon is going in what orientation and in what way. So it's a little bit of the secret sauce about taking a frame shape and making it ride and perform the way we want it to.
You've already heard the name of one of the world-class engineers that Mike references. Earlier, Frank mentioned Thanos Drivas. The other engineer is Richard Matthews. They both worked at Cervelo in the past. Their latest gig at Bridge is actually only 3 kilometers south of Cervelo's former Toronto head office.
Yeah, for most bike companies and most companies in general, your laminate schedule is your biggest proprietary thing. So that's what makes the ride feel a certain way. That, as Mike said, that's what makes it stiff or strong in a particular way. So everything comes down to what that schedule is. And again, before we have a complete bike, we can only do so much with understanding the strength of the bike and the stiffness of it before riding. And then as soon as you ride on it, your bum will tell you, your shoulders will tell you that, okay, this is too stiff or that's too, and then you got to iterate again.
It's essentially the deeper, more complex version of what kind of carbon are you using and how. So, you see some of the big bike brands will say, oh, we're using Toray T800, 700, T1000 is the lightest and stiffest. But the reality is that grossly simplifies how the bike is made. And so it's really all about how are you using all these different types of carbon fiber and the pieces you're using in what way. And as Frank said, you're talking about give or take 500 pieces of carbon that go into a complete bicycle. So obviously the nuance in terms of how those pieces go in, whether it's a certain type of carbon fiber, what the level of carbon fiber, and then how it's used in the bike really comes together in terms of how the bike performs.
I appreciate Mike's comment about how the laminate schedule is really a more important factor in the bike's construction and behavior than the type of carbon fiber it's made of. In my 10 years of reviewing bikes, I've rolled my eyes numerous times when some bike companies hype their frames with such lines as, "We use aerospace-grade carbon." Sure, that's great. It's not like those companies harvested the carbon off of jets, collecting supersonic speed along the way. I really appreciate how Frank and Mike are showing me how their bikes will be made. There's no flim-flam. And they plan on showing customers around the factory too, after production is fully up and running, likely in midsummer. Next, Frank talks about how a part, like the head tube, is made.
We use a process called latex bladder molding. So we have a latex bladder that you actually wrap the carbon around, and that forms your raw carbon part that's then put into here.
Frank points to the head tube mold.
and you put air inside of the one bladder, close the mold, put it in the press, which puts about 20 tons of pressure onto the mold and heats it at the same time, and the air puts about 200 pounds of pressure on the inside of the part. So that's how you form a hollow carbon part.
This part still needs some work after the baking process. It might need to be trimmed or have holes cut into it. It needs to be sanded and prepped for bonding and paint. After all the parts are made, they're bonded together with the help of a benchmark frame building jig. The bonds then get carbon fiber overwraps. Next, it all goes in an oven for final curing. The team at Bridge isn't at the stage of curing complete frames yet. The week after my visit, they're hoping to get a front triangle together. They'll test it with an Instron machine to make sure its strength and stiffness meet their standards. Well before my visit, to check the quality of their parts, they cut some of them in half.
Mike is showing me this a cutaway head tube and the sort of extension from the head tube that would go to the down and top tube.
Yeah, and sorry Mike, if you don't mind, the very important part to look at here is these sections that have more material in them. These are what you really look for when you cut the part apart, because that's where the most amount of voids could possibly be.
You're pointing to the part where, say, that what we call the down tube is meeting the head tube, and right at that sort of junction area on the underside, I can see it's thicker there.
Yeah, it's where the steering column goes in, and obviously a lot of pressure from the steerer and from the rider, from whatever they're doing, is going into, a lot of force is going into this area. So what we're trying to do here, and you can see the fibers going this way.
Right, they're following the shape.
Going into the down tube. So the strategy here is to put as much force as possible from the steering column down into the down tube, which is a much bigger tube, can take way more force on it and whatnot. So that's the strategy there. But the big thing for us is there's absolutely no voids in any of these sections. So I'm sure a lot of people have seen popular people on YouTube cut frames apart, and they're always pointing out voids and wrinkles and everything like that. For us, this was the first part that we made, and it came out very, very well.
Mm-hmm.
And to give you a sense, we're already on, I think, iteration number 8 of the head tube alone. So, the inside of the frame, that's where we are producing it here and want and need it to be an incredibly high quality. So we limit potential failures and make sure the bike is as perfect as it can be. And because we're doing it all in-house, we do have the ability to iterate quickly and kind of produce over and over and make it better each time.
The biggest benefit for making something local is that you know every single part of that bike from the inside out, everything. I would hazard to guess that those who are making their bikes across seas, the engineers that design that, do not know what's inside. And that's, in my opinion, obviously they're doing a great job. I don't want to bash anybody, but if you don't know what's on the inside of your carbon bike, you don't really know what that bike is.
It's a bit of a leap of faith on the engineer's side if you're sourcing it.
Or absolutely, or the people who are making the bike over laminate it. Or they put more in because they're not as in control of their processes. But don't get me wrong, there's obviously tons of factories doing fantastic jobs. It's just you fundamentally don't know what they did to make your bike.
To use a record analogy, they refer to the outside of the carbon parts as the A side. It's the side everyone sees. It's the more popular side, the hit, if you will. The pair spent about a year working on the A sides. Then they spent roughly another year working on the B sides. That's the inside of the frame parts. To keep running with the record analogy, the B side is the deep cut. Those in the know will appreciate it. In the factory, we joke that Mike and Frank should give tours of the inside of their finished frames later with an endoscope. They do have such a camera for inspecting their tubes, so maybe it's a possibility.
This is our freshly baked part, so this was...
right now that looks like something, a piece of plumbing. It almost looks like PVC pipe.
Yeah, totally, man. It's plastic, really, right?
I meant to say ABS, not PVC. ABS is the stiffer black pipe running through parts of your house.
So they're tubes, right? So they're a complex geometry and a complex process to make hollow tubes. But this is the headset. So a top tube comes out here, down tube comes out here, fork goes in here. But what I wanted to show you was the B-side. So this is our most recent one, and we've improved so much. Like, you could, when you remember looking at the other one, it looked a little dry. You had weave in there, which we don't have anymore. So you can see on the inside how clean that is.
I'm just gonna stick my finger in
Yeah.
here. It's pretty smooth, like my finger's catching here.
Yeah, that was just cut.
Right.
So I would ignore that for now. That's just a rough cut.
Right, but no, it is smooth on the inside and not quite as smooth as the outside, but pretty darn.
Yeah, and it shouldn't be as smooth as the outside. So what you're looking for on the inside, well, one, just mostly it's a visual.
Okay.
You can just see that there's no excess epoxy, there's no wrinkles, there's no voids that you can tell, and it's very, very smooth for a B-side. So this is a point of pride for us for sure.
This episode is supported by GCN Plus. GCN Plus has a ton of live race coverage. Earlier this month, I was on GCN Plus watching Matej Mohoric and his dropper post rip down the Poggio during Milan-San Remo. Before that, I watched his fellow countryman Tadej Pogacar take Tirreno Adriatico. Now, I'm looking ahead to the Tour of the Alps, the Tour de Romandie, and, of course, the Giro d'Italia. If you want to catch the first Grand Tour of the year, you need GCN Plus. GCN Plus also has more than 100 documentaries that cover pro riders, gravel adventurers, and even bike technology. You know, usually I'm out on a few longish road rides by this point in the year, but other than commutes, I'm still riding inside. That's partly the weather's fault, but I think GCN might be a bit to blame here. It's a breeze to catch up on races I've missed or check out documentaries as I ride the trainer with GCN Plus casting on my TV. It's all ad-free. If you haven't already subscribed to GCN Plus, you should do so. Canadian listeners, you can get 25% off an annual subscription. Head to gcn.eu/Canada25. That's gcn.eu/Canada25. Sign up and start watching. Now, back to the episode. After the factory tour wraps up, I still have some questions. I want to know more about the bike Frank and Mike are planning to build. What kind of bike is it? What are some of its specs? We head to Frank's office where Mike covers those details. While it made sense for Frank to lead the factory tour as he's set up production facilities before, it's fitting that Mike takes me through the bike they're planning to build. For more than 10 years, Mike has been helping customers at his shop, Blacksmith Cycle. He's helped those customers get their rides dialed. He's also set me up with test bikes that I've reviewed.
So our first bike is named Surveyor. I would describe it as a modern all-road bike. And by that I mean it's got the geometry that's very close to a road bike. So raceable, fun, agile, reactive. But then it's got the tire clearance very close to a gravel bike. So we're going to squeeze about a 40 millimeter tire in with plenty of space. So meaning you could probably run a 42 millimeter slick under the right conditions. And I believe that tire size is one of the key contributors to ride quality. I think the days of 25 millimeter tires are pretty much dead. You're seeing brands like Zip and NV manufacture their new race wheel sets around 28 millimeter tires. So we wanted something that really could be sort of an N+1 killer. So a bike that you could take on a group ride and that'll be fast, aerodynamic, light, but then that you could take on a gravel ride or race an event like Unbound or even Mid-South, that the 42 millimeter tire clearance really satisfies that need. So as a small manufacturer creating a first model, we kind of really wanted to throw a blanket over what we thought were the best attributes of road and gravel bikes in creating our all-road model. So we've got, I believe, the shortest chain stays for the tire clearance we have in the industry.
As Mike continues to describe the bike, pretty dispassionately actually, I know that the process of designing the Surveyor had to have a kid in the candy store feel for Mike. In a sense, this process has turned the tables on Mike. Usually, he's guiding customers in his shop. He helps them build custom bikes with the builders he works with. He's seen people spend hours mulling over the smallest details. But think about all the details and the range of decisions Mike had when he was designing a bike from scratch. He did admit to me that there were moments when he'd get up in the middle of the night to start comparing specs and geometry of bikes as he weighed his own decisions. As Mike speaks, you'll hear a dog barking in the background. You would have thought that the office would have been quieter than the factory, but a guard dog at the auto shop next door was, well, doing his job. Mike had even asked its owner if the dog could go inside as we recorded. The guy at the shop said he could after he got back from running errands. If he brought the dog in before he went away, it would terrorize the other employees at the auto shop.
We wanted a bike that also kind of was a modern classic. So by that I mean we've got fully internal cable routing, a D-shaped down tube for aerodynamics, ultra thin seat stays that wrap around the kind of seat junction for comfort. But we also wanted something that looked like a traditional road bike, that didn't have drop seat stays, didn't have drop chain stays. So a lot of the engineering focus was how do we keep that rear end tight while maximizing the tire clearance, and also focusing on some really functional things that most consumers will never see, like the amount of space in that chainstay for cable routing, the wall thickness of those chainstays for durability and stiffness, obviously. We're using a T47 86 bottom bracket. T47 we think is really the best option in the industry right now. It's threaded but allows you to run a 30 millimeter crankset spindle and or provide more space for wiring if you're running Di2, for example. So yeah, it's a bike we really think satisfies the riding that kind of 80 to 90% of us do. On the road side, it's not a true crit racer. On the gravel side, it's not a true adventure bike that'll clear a 50 millimeter tire and has, external mounts for bike packing. But kind of everything in between, from road racing to light gravel, we feel like our bike is super capable across a broad spectrum. The other thing is, as a startup, most bike brands, almost all bike brands, have a pure road race bike and they've got a full-on gravel adventure bike. But I thought there was a real space in between that bike brands are not paying enough attention to. And because we're not trying to go sponsor a pro tour team, we don't care if our bike, is 3% less reactive or aerodynamic than a pro tour race bike. And because we're not trying to sponsor gravel racers specifically, we weren't too worried that it wouldn't clear a 45 or a 50 millimeter tire. But that kind of 28 to 42 millimeter tire that I think the vast majority of us run is really what we wanted to design the bike to be based around. And so we're really excited. I mean, I'll say, in terms of the bikes I've designed with manufacturers over the last 5 years, the focus for me has been on this kind of all-road gravel category. But really, it's how do you create a bike that you can ride on road and gravel and that it's not going to be compromised? I've ridden gravel bikes with road wheel sets and tires, but then you typically end up with something that's really slow handling, ponderous, heavy. Or a lot of the modern road bikes will clear a 32 millimeter tire, maybe a 35. But for real gravel riding, we think a 38 or 40 millimeter tire is where you need to go. So that's really what we tried to design. There's some novel features that got us there. We've got actually an offset seat tube bottom bracket. So essentially stealing a little bit from the mountain bike world, where our bottom bracket is actually offset slightly, so that gives us a little more tire clearance, but keeps the chainstays short. So there's a lot of hidden engineering that went into this bike, but hopefully something that, when you look at it, still looks like a classic road bike has always looked, but has the we've maxed out the tire clearance and kept the geometry really tight and fun.
Mike and Frank have a cool factory that's just about to start pumping out what sounds like a pretty well-crafted and fun bike frame. But why start a bike manufacturing facility here in Toronto? Frank gave me some clues during the factory tour. The level of control and quality they can achieve here seem higher, or at least they seem easier to monitor. Also, Frank has always simply made stuff in Canada. You could call it his default. Mike has had opportunities to work closely with manufacturers overseas, but has similar reasons for making something here.
I think there are a number of reasons we wanted to build bikes domestically. Number one, we thought we could build a better bike. Better attention to detail, closer interaction with our engineers and designers and laminate specialists. The fact that the two co-founders can walk the factory floor and be intimately involved in the process. So we thought we could build a better product here, but I think we also wanted to support North American manufacturing in terms of hiring local people, being environmentally responsible in terms of the way we build those bikes, and having a closer connection to our customers. We think our North American market will be our biggest market, and the fact that a customer can come to the Bridge factory, do a factory tour, see their frame getting built, come to a group ride out of the factory, which we are planning on starting this summer once we've got some bikes. There really was no reason to consider doing it overseas other than cost. And I'd say personally, those opportunities that had presented themselves to me in the past were always about getting involved with a bike company producing overseas. And I didn't have a whole lot of interest in flying over to China or Taiwan 6 times a year to oversee production. It was never even a consideration to do it anywhere else. We're proud that we're bringing carbon fiber production back to Canada in some ways. There's, I don't believe, another brand building carbon road or all-road bikes in Canada. And we thought it would create a better product and a better consumer experience as well.
The pair have a top-notch factory and top engineers, but will they have enough people with carbon fiber expertise at all levels? Despite some of the challenges Frank and Mike have noted about overseas carbon manufacturing, countries like Taiwan and China have many experienced people, from the workers who lay up the carbon right on up the line. Is there enough expertise locally for the Bridge Bike Works operation?
Yeah, the expertise in making carbon parts is, I would say, available in Ontario and in Canada. It's there. We've got a lot of job shops in Toronto where people get a lot of carbon experience with. I would say maybe less so on pre-preg stuff, but we also have a business called Multimatic that's in Ontario that we've benefited from, and a lot of other shops have too, because they've trained them in actual production work in pre-preg. They make a lot of high-end car chassis, which we just benefit from because people want to change or whatever it is. But there is talent here. There's very high-level talent here, so you can get your senior composites people. But when it comes to actually laying up the carbon, again, it goes back to that process. Right now, we're ironing out our process so that when we do hire, let's say more, how would you call them, general labor composite technicians, people doing the layup, not designing it, literally just hand laying, they're following instructions. And the number one thing that you need from those people is attention to detail and care for where those pieces of carbon are going. That's the number one thing you have to look for. So in many respects, for those people, you don't need a huge background in composites, if anything at all. You can look into a lot of different industries where people have learned and or a natural desire for that attention to detail, whether it's in textiles, which is very similar to carbon, which is interesting. Carbon is a material. You use patterns, you use knives, you cut stuff up, and you put them in the order that they need to make something. So there's a lot of areas that you can dig into to find those individuals, but you really just have to vet them for that attention to detail.
I bring up the idea of naivete. It might sound like a harsh word to use, but I had heard Frank use it before. What was the role of naivete when these two started building this company?
Naivety is an interesting thing in my mind. My experience in entrepreneurship, it kind of needs it. It's one of the characteristics that I would say that allow you to make a jump. So you need a lot of courage starting anything. Naivety allows you to not understand how complex and potentially how challenging it could be. So then you just need your resilience to get through the stuff that you didn't really know about or the naivety that you had. And in our case, I think I can speak for Mike here too, the naivety was interesting because I came from a world where you just make your own stuff. I mean, that's what you do. If you're a new company and you're getting into trying to make and sell a new product, you make it. You're the manufacturer. Whereas when I came into the cycling industry, I kind of had the perspective that that's just what you do. And then the deeper I got into it, and Mike probably had a lot more knowledge in this area than I did from an industry perspective, you realize that that's not really how it's done. So that naivety in my mind has its ups and downs. You don't want to be too naive, but clearly once you jump in, you're going to figure out a whole bunch of stuff that you're never going to do before you jump. And again, naivety is sort of critical to that, for better or worse.
You know, on my end, having run a bike shop for a decade, I probably thought I knew more about carbon production than 99% of the population. And I might have, but I've now realized how much I didn't know. And, you know, this 2 years has been an amazing education and learning curve in terms of engineering and the complexities of carbon production, manufacturing in general, and just starting your own business. So I think what Frank said is on the money. If I had known what I know now, I probably would have been a little bit terrified. But as he said, I think it's, you know, you just keep working and grinding. And I think the passion for the project and what we're trying to create allows you to kind of just plow through all of the minutia that maybe you didn't expect. And you learn a lot along the way. And I think it makes you a better, more capable, more well-rounded person. But, you know, I think if you ask 100 people, would they start a bike brand, you know, 70 of them would say you're crazy. And I think that little bit of craziness is a good thing in terms of being an entrepreneur.
Naive, crazy, ambitious? Maybe all three, carefully laid out in a laminate schedule of qualities, is what you need if you want to make a carbon fiber bike right here. So what's next for Bridge Bike Works? Well, the team is jamming to get their first bike out this summer. In the future, they plan on creating a more road-focused bike, a hardcore gravel adventure bike, and even an e-bike. The first frame, the Surveyor, will have its own in-house fork. That leads me to ask about other components. Mike and Frank say it's possible that they could make their own seat posts, stems, bars, even rims. They have the equipment after all. Right now, about 10 people will be doing all the work at Bridge. But by the company's 5th year, it could be making 1,500 to 2,000 frames and have as many as 30 employees. Once the Surveyor is ready later this year, you'll be able to order it through Bridge's website or through dealers that the company is planning to work with. The target price for the frame and fork is $5,000. That's a few $100s less than an Allied frame made in the US. It's also in the ballpark of many top frames from the big brands. I hope Mike and Frank's plans and ambitions go smoothly in the months ahead. Their clean factory is sure to get busier and noisier. I also hope to come back in the summer to see complete frames and maybe even ride one myself. That would be pretty cool. And that's the episode. It's written and edited by me, Matthew Pioro. I had help from associate editor Andre Chuk, as well as web editors Matt Hansen and Terry McCall. The Canadian Cycling Magazine podcast is produced by Adam Killick. He composed the music too. Thanks to Ontario Creates for its support. And thank you for listening. Please rate and review the show, ride safely, and I'll talk to you later.